Good afternoon, dear students. Last lesson we were working with matrices, different operations such as addition, subtraction, multiplication, inversing matrix, and elemental transforms in order to find rank or inverse matrix. Today we are going to solve systems of algebraic linear equations. And the first question is, which methods do you know? Who wants to be the first? Maxim? Yeah?
There are three common methods: Cramer rules, Gaussian elimination method, and the method of inversed matrix.
Yeah, correct. Okay. So who wants to tell me about Cramer method? So who will be the next? Adrian, go on.
We convert a system of equations to the matrix and then find four determinants, and we like all three matrices, all three determinants, we will delete with the first one.
Okay, not I understood your answer. Actually, this is correct for the system of three equations, but you can have 10 equations, 100. So actually, we need firstly to evaluate the determinant of the equations matrix, coefficients before variables, and then we sequentially substitute the column of matrix with the column of free coefficients. Yeah, and then divide each determinant by the general determinant with only coefficients. And yeah, we will find the solution. Okay. So the next, who want to answer about inverse matrix? How to solve? I want to hear everyone. So who will be the next? Who will be a volunteer? I want to hear new people. Okay, maybe Daniel?
We need to transpose our matrix, and after this we calculate cofactors of this matrix and find the inverse matrix. And after this we multiply our inverse matrix by solutions.
Yeah, actually, the answer is correct. But I will correct you a little bit. So actually, it is only like the method of finding the matrix with using cofactors. Also, we can find it with the elementary transforms that we did last practice. So different ways to find inverse matrix. But the main idea to multiply vector of coefficients in the right part by inverse matrix of coefficients before variables from the left side. Yeah, so actually it's the main idea. But it's good that you mentioned determinant. And here is the next question for the next person. Actually, for which systems can we use matrix method and grammar formulas? Who wants to answer?
Only for square?
Yeah, only for square and the other condition, important so on as well. So, Mykola, can you answer?
Unfortunately.
Unfortunately, okay. So, who wants to help? New person. Maybe Masha. Do you know the answer? Yeah.
Not really, I'm sorry.
Sorry, I don't hear. You can post in the chat, actually, if promos with the sound.
Determinant is not equal to 0?
Yeah, so the determinant must be not equal to 0. So you can't divide by 0, and we need to divide by determinant. So we can't inverse matrix with a 0 determinant, and we cannot divide by 0 when we use grammar formulas. So this is correct, and let's start solving. So let me share my screen. Okay, so that's the first example. Let's solve it. Let's start solving it together. And about Gaussian method, we will talk a little bit later. It will be good if you help me. So if you take part together with me. So let's firstly calculate. Not these tools. So firstly, let's calculate the determinant of this of the whole matrix. So 5. 3, 1. By the way, do you see good or not? Or should I zoom in?
It's okay.
Okay, so anytime if you don't see, feel free to ask me to zoom. And let's name it just delta. So who will name addends? Let's calculate together.
Sorry, but element A 3 supposed to be 7.
Thank you for your attention. Yeah. Confused with this one. Yeah. Okay. Yeah. So let's go on. So who wants to assist me? So, okay, so let me ask anyone. Disconnection issue. So, what do you remember, so when I disconnected.
Which methods should we use?
Grammar method for now. Actually, the first example for grammar's method. So let's calculate determinant together. So who wants to assist?
I want to try.
Okay, go on and
Firstly, we
the
should
details.
solve the determinant. 35 minus 6
Go on.
and minus 25.
35 plus 15. So yeah, we multiply minus 3 and minus 5. So
Oh yeah.
this triangle, yeah. Okay, and then
Minus 1. Minus 50
correct.
and plus 63.
Correct. Okay. And now let's quickly calculate it. So what we have now, 60,
58.
58. Okay, I will trust you. Okay, let's check it. So determinant, yeah, 58. I'm not sure. So
Oh no, 56.
yeah, 56. Yeah. Okay, and
About
then the first determinant 1, which columns are modified, or which one is modified?
first column.
Yeah, and what should be in the first column?
2, 4, 3, minus 3, 1, 2, minus 2.
Yeah, so actually second and third are not modified. Okay, who wants to calculate together with me the next person? Stanislav, go on.
It will be 14 minus 8
Mhm.
plus 45, and then minus 3 minus 20 and plus 84.
And now let's calculate. So 59 plus 84, 140. It must be 112.
Yes, I have similar answer.
112. Okay. Yeah, by the way, so the determinant is not 0. So just let's write it as well, so that it means that the system has solutions. Okay, so now let's calculate determinant 2. Who will be the next? And which column is modified now?
The second one.
The second one, yeah. Okay, so let's write it 5, 3, 1, and here 2, 4, 3. 1 minus 5, 7. So Yevgen, continue helping calculation.
Do you hear me now?
Yeah, yeah.
Okay. 140 minus 10, and then plus 9 minus 4 minus 35.
Are you sure?
Не те число побачив.
Yeah, so, yeah, 2. So my bad.
32,
Uh,
42.
42, yeah.
And
And plus 75.
Yeah, plus 75. And the final
Sum
result,
is 110.
100,
10.
110. Are you
Oh.
sure?
Oh, it's not.
168.
Yeah, 168. Okay, yeah. And let's calculate the third determinant. So this comes, which is changed actually. Which,
The
third one.
this third, yeah. So this will be without changes, and I'll just, to save our time, I will copy and paste it. Just to save our time. Okay. Who wants to be the next?
Could I make that one?
Just raise your hand. Dmitro, go on.
Yes, so the result will be 15 minus 12 minus 12 minus 2 plus 40 and plus 27.
And the final
56.
56. Okay. So now let's calculate it. So the x1. So how to calculate x1? I want to hear new people. So Stanislav, Masha, Evgen, someone new. Oh, Alexandra maybe. Oh,
Okay. So we should find the x1, yeah?
yeah.
That one, that two, that is 3. Yeah, 56 plus 2.
So do you see all determinant values?
Yes, I lose them.
Okay, let me just circle them. Just not to lose. So
So it will be 56 plus 56 plus 112 plus 168.
are you sure that? By the way, do you remember the formula how to find the final results of the variables if we have all determinants?
Actually, I don't remember. That's the point.
Okay, and who wants to help someone new? If I'm not mistaken, Artem raised the hand last time.
Yeah.
So
So basically the formula is like to divide the determinant with number one by the determinant.
yeah,
Like
so
112 divided by 56.
yeah, so delta 1 by delta. Alexander, did you understand the idea?
Yeah, I understand. So,
Yes.
yeah, I already remembered. So then we will мы поделим 56 на 168, потом следующее действие. Это будет ответ 0,5, по идее.
Are you sure that you divide in the correct order? So what should we divide to get x2?
168 divided by 56.
Yeah, by 56. So and so it's not
Yeah, I say it in the wrong order.
Yeah, so it will be 3 actually. So be attentive. Don't forget that that we must divide by this delta general without any indices. Okay, and x3.
It will be 1, so 56 divided by 56.
Yeah, but let's write it in details as well, just for better understanding to remember. Okay. Okay, now let's just verify the solution. So actually, we see that we have it matches answers, but what we don't be lazy and just verify. So 5 by 2 minus 3 by 3 plus 1. So 10 minus 9 plus 1 is 2, correct. So 3 by 2 plus 3 minus 5. So 6 plus 9 minus 5, 4. Correct. And the last one. 2 minus 2 by 3 plus 7. So 9 minus 6, 3. So everything is correct. Yeah, and actually it's a verification, but when you verify, don't so spend a few minutes just to check all equations. So 3 not such a lot. So please check when you do your homework, your individual tasks, tests, and so on. Actually, this is the analogical example. So we will skip it for now, and you will do it at home. Or maybe if we have some time, we can return to it. Maybe you have some questions for now about Kramer's formulas.
No.
Okay. Sorry. So
No question.
Okay, no questions. Okay. And now let's use the matrix method. I will erase it just with creating a new file. Okay, so let's write the matrix of our coefficients. And B is a vector column of three coefficients, three members. So, and how it actually looks like our equation system. So AX equals B. And to get the solution, we must do the next actions. So we multiply by inverse matrix from the left side. And then just let's simplify. So X, yeah, actually it's identity matrix. And X equals just inverse matrix A multiplied by B. And it will be the vector of X of variables that we will find. So now let's calculate cofactors. So who will be, no, let's better firstly calculate determinant. By the way, we can mark a determinant in this way, det A or just delta, actually as you like. Or maybe like a module, doesn't matter. Sorry. Yeah, so delta or like the same as module. So different ways to mark it, and now let's calculate. Let me copy and paste it for saving our time. Okay, so who wants to answer? Who wants to assist me? I want to hear
Okay.
new people. Daniel, you already answered, but maybe you will have a chance. But the first priority is for new people. So don't be shy to answer. Don't be afraid of making mistakes. Raise your hand and let's calculate. Okay, maybe Alexander Kanivets. Do you want to be a volunteer?
Oh, I'm sorry, I was not present on some lectures and actually revising the material right now.
Okay, so let's do it now. Let's start revision right now. Do you remember actually how to calculate the determinant of the third order?
Yeah, by the triangular
Yeah,
rule.
okay. So let's use this rule. Use our lessons, our meetings to revise the material. Communicate, make communication useful. So
we have -3, then 1, plus 1. Oh, -9, I'm sorry.
Yeah, be attentive. Okay,
then -2. Oh, no, minus one. Minus one.
Minus 1, yeah. Don't
And
how?
then minus 8.
Minus 8, okay.
Then we have plus 2.
Plus 2.
Plus 6.
Mm-hmm.
And plus 6 again.
Yeah, plus 6. And finally, so 12, 14, 14 minus, minus 18, minus 4.
Yeah.
Yeah, okay. And let's verify actually our determinant. Yeah, minus 4, so it's not equal to 0, and it means that we can inverse our matrix. Okay, and actually that's for everyone. If you have any questions, if you don't understand something, feel free to ask, and even more, don't be afraid of taking parts in solving our exercises, in doing our exercises, just to improve your knowledge and fill your gaps. Understand?
Yes.
Okay.
Yep.
Yes.
Okay, and who will be the next? The next operation, what should we do? Co-practice, someone answered without raising the hand. Okay, and who wants to calculate them?
I have a question. Shouldn't we firstly do a transpose of the
Uh,
matrix?
we can firstly transpose. We can transpose later. Actually, yeah. Okay, we can transpose now. Will be a good idea. So, who wants to transpose? The new person, maybe Artem Orlov. Are you here?
Yeah.
Yeah, so let's transpose the matrix. So which coefficients will we have? How should it look like?
Honestly, I don't remember because I wasn't on some lectures as well.
Again, if you feel not sure, practice more. So let's do it together. So you don't remember how to transpose the matrix. Okay, so the rule is that we change the we like turn it over, and we change rows with columns, or vice versa. So do you want to assist me now to transpose the matrix? So which coefficients we will have?
I'd like to help.
I want to take part people who has problems. So firstly, just to refer to help and refresh your knowledge. But I guess everyone will answer today. So Artem, don't be afraid of making mistakes. So what will be the first row? Okay, Mikola, go on.
Okay, in the first row, 3, 1, 2. second, -2, -1, -1, and third 1, 2, 3.
Yeah, 1, 2, 3. So, Artem, did you understand the idea? Actually, we just make this column, we make a row, and this and this, or just vice versa. So, nothing actually hard.
So we basically make the columns rows and the rows columns, right?
Yeah, yeah, and remember that every matrix can be transposed, not only square. Okay. And now let's calculate cofactors. Who wants to be the first? Who wants to take part?
I'd like to take part.
Okay, new people. Let's hear new people. Let's listen to everyone. Maybe Daria?
Yes.
Yeah, so let's calculate cofactors.
So it will be -1 in power of 2, because 1 plus 1 plus 1 it will be 2. And then square.
So we'll look at
we will
this
have
matrix now.
-1, 2, the first column, and -1, 3, the second. So it will be 1 multiplied by -2 plus 2, it will be -1.
Yeah, -1. Okay. And the next. Okay, let's hear everyone on how to view all the list. Okay, I see that Danil raised the hand, so go on.
-1 in the power 3. Matrix -2. I will say row. -2, -1. 1 and 3. So we have -6 plus 1, and this is -5.
Just 5 plus 5. So be attentive. Okay, Mykola.
Row first, first row, third column, -1 in fourth power. Then we have -2, 1. Oh, -2, 1, -1, 2. And we have -3, you know.
It seemed that you confused a little bit rows with columns, but okay, never mind. So -4 plus 1, and it's -3. Okay, let's calculate other cofactors. 2, 1. Masha?
So -1 in the power of 3. And 1, 2. And the next second row is 2, 3. And it will be minus in the bracket 3 minus 4, and it equals 1.
Yeah, correct. Okay, the next. Okay, Mykola. Adrian will be the next.
Okay, the next is which exactly? 2,
2, yeah.
Okay, you will have minus 2 in power fourth, in fourth power. 9 minus 2 is 7. It's
Oh,
7.
okay. Tell me coefficients.
3, 2, 1, 3.
Yeah. So let's do everything in details. So 12.
2, 3, not 4.
Yeah. So my bad.
9 minus 2 is 7.
Minus 2, yeah, 7. Correct. Okay.
I can tell all the rest if you need.
Okay. Let's tell the rest, and Adrian, you will answer the next question. Okay, so Mykola, which cofactors?
2, 3 is minus 5.
Mm-hmm.
3, 1 is 1.
Mm-hmm.
3, 2 is minus 1. And the last one is minus 1.
Mm-hmm. Okay. And okay, Adrian, your turn is to name actually the whole inverse matrix.
The first row of inverse matrix will be -1, 5, and -3.
But don't forget. So, did you forget anything or not?
I don't think so.
Sure. What first we calculated to for our system?
Like, I can say what what inverse matrix look like.
Yeah. How does it look like?
Like the first column or the first row?
Actually, the general appearance of inverse matrix.
You have to create. Like, we just place the cofactors on the places.
Yeah, and we transpose, and just something is missing. Okay, Masha, can you help?
We should
Okay.
multiply it by the determinant. By
Not multiply.
-1.
We need to divide it by determinant. So just do like this in our case. And now, which coefficients?
The first row will be -1, 5, and -3.
Mm-hmm.
1, 7, and -5.
Mm-hmm.
1, -1, and -1.
Okay, now let's look at spoilers and find, yeah, so 1, 5 minus 3, 1, 7 minus 5, minus 1, oh, 1 minus 1 minus 1. Okay, so the inverse matrix is correct. So just, we have not so much time to multiply it by initial matrix and then get identity matrix. Okay, correct. So now
I need
let's.
minus. Sorry.
Do you have
Minus.
questions?
Minus before 1 false. because determinant is -4.
Yeah, determinant is -4, so just don't forget it, this minus. And actually, that's all. So either here or here. And now, who will tell me how to solve? Okay, Stanislav. So let's calculate x.
To find an x, we need to multiply a powered by -1 on b.
And now let's do it. By the way, let's make it simpler. And this. Okay, so for now, let's leave this coefficient here. Then we will multiply every coefficient in the result. So actually, now we will get a vector, and who will calculate it together with me? Who will assist? Okay, Daniil?
1 multiplied by -1 plus 1 multiplied by 5
No, actually we must 5 multiplied by 3.
Plus 1
Minus.
multiplied by 1.
Sorry. Okay, let's start. So we need multiply this row by this column.
Plus -15 and
Yeah,
plus
-15.
and plus 12.
Yeah. Okay.
Next row is 1 -21 and plus 20. Then 1 plus 3 and plus 4.
Okay, and -1/4. So what we actually have, so
-4 in the first row.
Yeah, -4, and here 0, and here 8. And actually the result is 1, 0, -2. And let's check if it's correct. Yeah, so 1, 0, -2, and now let's spend just a couple of minutes to verify. So 3 by 1, so -2 just skip. -2 is 1, so then 1 minus 2 by 2.
Can you show the answer once again?
This is the answer.
Thank you.
So -3 and 1 by 2 minus 2 by 3 is -4. So actually, yeah, so we verified the result is correct actually, and the other way to verify, to multiply your inverse matrix by the initial matrix, spend some time to do it when doing your individual tasks just to be sure that everything is correct. And now let's have a break, and after that we will have so we'll use the Gaussian method. And now let's by the way, do you have any questions for me or not about this task, this exercise?
No.
Okay, no questions. So now let's have a break for a few minutes, and then we'll continue. let's continue. Okay, what do you remember about Gaussian method? Who wants to answer? I want to hear new people. Maybe Denise, can you answer this question?
Firstly, we should write down the augmented matrix of the system and then multiply it by the answers.
Well, actually, we have the matrix of coefficients, and it has some values, and actually, which so how should it look like? We did some actions which, in on our previous lessons before we used so which we will use in Gaussian method. So could you repeat the answer? Maybe I understood you incorrectly. So Denise, could you repeat your answer, or so what did you mean actually? So we have the matrix, and how should it look like when we use Gaussian method? So to which form do we transform it?
If we have the
raise your hand firstly, who wants to? Oh, oh, Denise. Okay, yeah. So what do we should have?
If we have a system, we should write down the augmented matrix of the system.
Mm-hmm. We have it.
And
this is the matrix.
then multiply the rows помножити на те, що в системі дорівнює.
Understood. Okay, so you mean so like to make it triangular, correct? So actually, all elements under the main diagonal will be zeros. So actually, this is the idea. So to triangular form. So we do elemental transforms for in Gaussian method. You actually used it in school. So when you had such a system, so for example, this one, then a2x plus b2y is C2. And you just, so what did you do? You eliminated either X or Y, and here you had only one variable. And actually it was Gaussian method. You excluded, eliminated one variable and found another, and then found everything. Actually, it's a Gaussian method, but just for two variables, and now we will use it with more variables. So any questions for now or not?
No.
Okay, so now let's start solving this example. So what we should do, we need to expand our matrix for doing elemental transforms. So it will be it will look in the following way. So like matrix A, and then we will write a column of 3 members, 3 coefficients. And here just 1, 1, and 2. And now let's start transforming this matrix. So I suggest you put in the first this line on the top, because it's already transformed. We have 1 before x. So just to save our time. So 1, 2, minus 3, and 1 here. Okay, and let's eliminate these rows. Who wants to assist me?
I want.
Okay, go on.
Oh, you change.
Yeah, I just put it on top. And I need to eliminate this and this. By the way, if we change equations sequence in the system, so if we just swap this and this, for example, nothing changes. Agree? So actually the same is here with the matrix. We do the same operation.
Okay, I just.
So, okay, let's eliminate this row. What will we have here?
No, I write already. 1, 2, minus 3. Okay, we have. I really don't understand because it's shaped in not like my.
Okay, let's okay. Without skipping, let's write the whole this matrix without first we change the rows. So in this way, just we write it, and now what we should do. I want to eliminate these elements.
Okay, firstly, we should multiply first row by 3 and minus second row.
So
minus 8.
And
five. Minus 2, minus 4, minus 5. In a second row, in a second column. In the second column, a third element.
Minus 5, are you sure?
In a second column, third row, minus 5.
Let's firstly calculate this row. Let's calculate by rows and then by columns. So
Okay, it's
row by row.
6.
6, yeah.
And third row is
don't hurry, we need to calculate this coefficient as well.
Okay, it's minus 2.
Minus 2, okay. And the third row?
Minus 5. And 4. No, it's 5.
Yeah, 5, and here
it's 0.
0. Okay. Correct. And actually, how can we simplify this matrix? I will copy and paste it and just move to the next line. So, what can we simplify in this matrix already without evaluating any, so without eliminating rows and so on. So what can be simplified here? Any ideas? Daniil, yeah?
I think we can add third column to second. So we have
No. So we can do something before, just to simplify our calculations. Before adding, subtracting, multiplying, and so on. How can we simplify our system?
Divide the second row.
by 2.
Divide second row by 2, and what else?
And the third one by 5.
Yeah, correct. So just to simplify our calculations. So here we have minus 4, 3, minus 2, and here minus 1, 1, 0. And now let's just for more convenient calculations, I will do the next actions. I will swap these rows. So actually, yeah, if you divide both sides of the equation, nothing changes. So what we actually did here? Minus 1, 1, 0. Here minus 4, 3, minus 1. And what else I want to do? Just to simplify our not equals, actually, like this equivalent or this arrow. So what we do? So I want to change the sign here of the second row.
Multiply by minus
No,
1.
yeah, multiply by minus 1. So actually just change the sign, and now we have such a matrix.
And then second row we multiply by 4, add to third.
Don't hurry, let's go to the next line and write it. So don't use such tilde. Yeah, so first and second row currently are without changes. Here we need to receive 0, and actually what do we have here? So who wants to assist me? Just raise your hand and let's calculate. Yeah, okay, Mikola?
Okay, we have minus 1.
Yeah, minus 1. And by the way, minus 1, yeah, minus 1 and just minus 1. So, and it was actually the, like, how to, I don't remember. Yeah, so forward elimination. So forward way of Gaussian method, and now we will rewrite our system. So just x1 minus 2x2 minus 3x3 equals 1.
No, in first row is incorrect. We plus 2x2.
Thank you for your attention. Yeah. Losing sign is a bad practice. So x2 minus x3 equals 0, and minus x3 equals minus 1. So now we will go. So now we start the next stage, is which name is forward elimination, or not forward but inverse elimination. So what do we have? So x3 equals 1. So we found it. Now x2 equals, oh, by the way, anyone wants to help? Mikko already just answered. Yeah, you can. Yeah, so what are we doing now?
x2 equals minus 1.
By the way, don't forget to write in details. So x3 equals 1. So we just eliminate minus here and have this one. And x2, so let's find x2. So spoiler.
As I say, it's 1.
So we know already x3, and we need to find x2 using this variable.
x3, it equals to x3.
Yeah, it equals to x3, and it equals 1. And then how to find x1? So what we do? We just, so 1 minus 2x2 plus 3x3. And it equals 1 minus 2 plus 3 equals 2. And now let's verify that it's correct. So let's look initial system. So 3 by 2 minus 2 minus 3.
By the way, it's correct.
Hmm?
By the way, it's correct.
Yeah, so 6. Yeah, it's correct, but let's verify. Let's spend our time. So if it's correct, you think that why did I waste my time for the verification, because it's correct. But if then you see that it's incorrect, you know that it was a useful thing. So let's have such habit. So it will be helpful for you. Okay. So do you have any questions now?
No.
And let's see. Now let's see the actually how here is suggested to eliminate to apply Gaussian method. So actually, what we did at the first stage. Yeah, so some stages are skipped here. Yeah, we simplified it, we reduced So divided by 2 here, and yeah, some of steps are skipped, but we did everything in details just to be more understandable for you. We can, yeah, Masha, any questions, right?
Yes, I have a question. I'm a little bit confused by the last step. How did we get this 0 in the third row, second column?
This 0.
Yes.
Okay. So we just multiplied it this row by minus row. Okay, I will annotate with zoom. So we multiplied this row by -4, and then just subtract it from this row. So -4. So here we have -4, here 4, and here 0. And we just subtract -4 minus 4 is 0, so 0 minus 4 is 1, and here nothing changes because we have 0 here. So now is it clear, or you need more?
Yes, thank you.
Okay. Feel free to answer questions. Maybe do you have more questions for me?
No, for now, no. Thank you.
Okay. Now I will clear all drawings, and let's see if we have some time to use more systems to solve more systems. Okay. So we will do it actually on the next lesson. Yeah, by the way, this system also can be solved by Gaussian method, by inverse matrix, and grammar formulas. And the next topic is actually for the next practical lesson. By the way, let's just look at exercise 6. So here we have 3 equations, but 4 variables. And we use the Gaussian method as well. And actually what we see here, when we just when we eliminate our rows, we see that here what we have, so 0x1 plus 0x2 plus 0x3 plus 0x4 equals 9, but 0 does not equal 9, and it means that the system is uncompatible. It means that it has no solutions. So with using Gaussian method, you can simply verify it. Maybe you heard something about Jordan-Gaussian method with the full elimination. Actually, we just transform our matrix to so this part to diagonal matrix or even identity, and here we will receive coefficients, but we need a lot of time for that. And now we have no time. Maybe any questions for me? Okay, if you have no questions, now we will finish our lesson. At home, you can already start doing individual tasks related to equation systems, but don't start homogeneous equation systems for now. We will do it on our next practice. So start solving equation systems, and it will be good if you review examples which we were not solving during our lesson. So goodbye everyone, stay safe and secure. Have a nice day.
Thank
Thank you.
you. Bye.
Goodbye.
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 Thank you for your attention.
Nice day for you. Goodbye.
Thank you.